Dear students, what we consider in this class is repeated games. As we have discussed earlier, in the oligopoly markets, firms often find themselves in a prisoner's dilemma when making pricing and output decisions. The question is, can the firms find a way out of this dilemma so that oligopoly cooperation and coordination will prevail? Can the firms find a way out from this prisoner's dilemma so that oligopoly cooperation and coordination will prevail over time? To answer this question, remember that prisoner's dilemma game is limited in the sense that the prisoners in our game receive only one chance to confess or don't confess. But in the real world, firms will get more than one chance. They can set a price or output again and again. That is, in real life, firms play what is known as repeated games. That is, actions are taken, payoffs are received again and again, again and again. So if there is a number of chances to take action and to expect the payoffs, the outcome will be different. In the case of prisoner's dilemma, both will confess and get more jail terms because they have only one chance. But in the real world, firms have a repeated number of chances to fix price or output and watch the outcomes. Now, if the prisoner's dilemma is a repeated game, then reputation will emerge over time and it will alter the outcomes. Repetition alter the outcomes because repetition alter the or change or enables reputation to develop. Let us see this with an example. Suppose that two firms A and B low price, high price, low price, high price, 10, 10, 100, minus 50, minus 50, 100, 50, 50. Now suppose now what is the Nash equilibrium for this? If A thinks that B will charge low price, A also low price. If it thinks that high price, high price. If B thinks that A will charge low price, high price. So low price is Nash equilibrium. Low price is Nash equilibrium for this game. Now the question is, if both are charging low price whether A and B have incentive to deviate. If B charges low price and if A shift from low price to high price, minus 50. Similarly, if A continues to charge low price and B high price, minus 50. So it is stable equilibrium. But it is not profit maximizing. If both charge a high price, the outcome is 50-50 rather than 10-10. So our firms are in a situation of what is known as prisoner's dilemma. Prisoner's dilemma. The question is why you are afraid of charging a higher price. The reason is simple. You are not sure about whether your competitor will also charge a high price. If you charge a high price and your competitor charge a low price, you will lose 50, whether it is A or whether it is B. That is why you charge a low price, your competitor also charge a low price, and both end up with low payoffs compared to high payoffs. Now suppose that the game is repeated over and over again. That is, they simultaneously declare the prices in the first day of every month. Then can we expect a different outcome? So in order to analyze Robert Axelrod, using computer simulation, derived at a surprising result. The objective of his simulation study was to find out what is the best strategy to play in the context of repeated games. That is, what is the best strategy if the game is repeated again and again. And the conclusion resulting from computer simulation by Robert Axelrod was tit for tat strategy. The strategy is tit for tat strategy. The best strategy is the tit for tat strategy. That is, suppose that you are firm A. You start with a high price. And you maintain the high price as long as your competitor also charge the high price. And if your competitor reduce the price, you also reduce the price from high price to low price. And the question is how this strategy works. And depending on whether this strategy works or not depends on whether the game is played only a finite number of times or an infinite number of times. Suppose that the game is played an infinite number of times. If the game is played an infinite number of times, then cheating and getting a high profit. Suppose that you are charging a high price and your competitor reduces the price to low price and earning a payoff equal to 100. That is only once, not an infinite number of times. So, the cumulative gain from cooperation outweigh the gain obtained from cheating once or twice. So tit for tat strategy works if the game is played an infinite number of times. Now suppose that it is played only a finite number of times, say 10 times. Now it follows that this strategy will not work because you consider the last time. Suppose that it will be played only 10 times, then the game is over. So in the last time, your rival will cheat by fixing a low price and it is known to you. So you will also do the same thing. So in the last, it is low price, low price. Then what about next to last? As there will be cheating in the last month, there will be cheating in the next to the last month also. And using this rationale, it is not possible to charge a high price and a high price. So the firms will charge only low price if the game is played a finite number of times. So this repeated games will enable the firms to develop reputation and cooperation, and provided that the game is played an infinite number of times. And in the real world, as it is known to you, the game is actually played an infinite number of times. So we expect all the firms earning high payoffs if, as in the real world, there are repeated, in the real world, as the games are played an infinite number of times. So this is what is known as repeated games. In the case of repeated games, let me repeat, there is a possibility of oligopoly, coordination and cooperation, and possibility of earning high payoffs. But there are so many factors which prevent the occurrence of this outcome due to various uncertainties in the market, uncertainty about price, uncertainty about demand conditions, and so many other things. And also remember this, open collusion is illegal in most countries.